Okay, perfect. So today what we are going to do is to build in Ethereum, but not only in Ethereum. When you learn how to build in Ethereum, this will help you to learn in any EVM compatible blockchain like Polygon, Avalanche, and there were some others that are EVM compatible. So today we are going to learn these things. I'm Santiago from ChainSafe. This is a research and development company from Canada. Started in 2017. We are really into open source products, public goods in the Ethereum ecosystem. I'm the developer relations for Web3.js. That's that little logo that you see in the corner. That's a JavaScript library created 10 years ago by one of the Ethereum co-founders, and we have around 2 million of downloads per month. So that's the short intro. This is what we are going to learn today. We are going to learn some Solidity. We are going to learn real-time ID, that is the environment to write smart contracts. We are going to learn about smart contracts, Web3.js, and we are going to deploy on Polygon as well in the Mumbai testnet. But if you learn how to deploy in Polygon, you will be able to deploy in the other EVM networks as well. Okay, so this is what we need for today. In case that you don't have, maybe you can start downloading some of these things. We need VS Code or any code editor that you want. We will also need Solidity language and themes. Oh, this is the theme, the extension that I use in VS Code, but you can use anyone. We'll need Node.js, MetaMask in your browser, and testnet tokens. Also, at the end of the presentation, I'm going to share these slides in Twitter, so you are able to access to all these things. Okay, so this is kind of the content that we are going to see today. First, we are going to start with a short intro of what is Ethereum. The second one will become better, and we are going to talk about smart contracts and Solidity, then blockchain interaction with Web3.js, and then in the fourth one, I will give you some next steps, some videos and tutorials that will help you to get started and learn more useful things in the blockchain ecosystem, so you don't struggle like I did a few years ago learning blockchain and falling into this tutorial hell that is not nice. Okay, so what's Ethereum? I have a question. How many of you know Solidity, for example? Okay, then that's great. Then you will learn Solidity today. JavaScript? Okay, that's perfect. And then the rest, do you know any other programming language? Java or C++? Okay, that's perfect. So then let's start with what's Ethereum. So Ethereum, I came up with these slides yesterday, but I think it's a really easy way to explain what is Ethereum or kind of any blockchain. I will define Ethereum as a decentralized, immutable database. This is decentralized because we have a lot of nodes and not like really specific servers. Like for example, Facebook, if you have Facebook and you have some servers in a country, if this server is off, then the whole Facebook system is off, right? But then in Ethereum, we have more than 10,000 nodes, I read a few days ago. So if one node goes down, then we also have another 10,000 kind of backing up everything, and every node has the copy of the whole blockchain, so the blockchain is really hard that it's off or it's down. It's also immutable because no one can really change anything in the blockchain. So, for example, in Facebook, if Mark Zuckerberg wants to change my name from Santiago to John, he can just do it, right? But then here in blockchain, that's not going to happen because no one has access to the blockchain itself to change the state of the blockchain unless you send transactions. And then it's a database because this is just that's the best way to define this. Is a database that will store a lot of transactions and smart contracts. So this is the perfect definition of Ethereum, decentralized, immutable database. We are going to do around 5 to 10 minutes of this theory, boring theory, and then we are going to do coding the rest of the hour. Ethereum is also shutdown proof because nothing will happen if 1 or 2 or 100 nodes goes down. We also have the other ones backing up. A big issue that can happen is that someone can take 51% of the nodes in the network, because then they can, in that case, they can manipulate the network and then they can do a lot of things. But that's also really hard to happen. You will need to have a lot of money in this case to be able to have 51% of the network. In Ethereum, now we see the new concept of dApps that is called decentralized dApps, because once you have a dApp and you deploy this in the network, no one can really change this. So if one dApp is doing certain functionality, no one can really edit this once that's deployed. So that's something really good about these dApps. That's also bad in certain points because then you cannot add features, but there is something new that is called proxies. That's more advanced, but this proxies allows you to upgrade smart contracts, but in this case, once you deploy something in the network, that's immutable. You cannot change that. And in Ethereum, we have Ether units. The three most common ones are the Ethers, the G-Way, that is the unit that you use to measure the gas fees, and the Way. This is like Bitcoin and Satoshis. If you're like familiar with this concept, that's the same. So one Ether is 1 to the power of 18 Way. And then you can go to ETH converter if you want to see this process. We are going to explore that as well. Okay, so now this is what we are going to talk about, smart contracts and Solidity. Let's start with what's a smart contract. So this is literally a contract that is in the blockchain. You need Solidity to write these smart contracts. I'll say that there is no human error in the smart contracts as long as you code something good, right? Maybe the error can be, well, you code this, but once you code the smart contract and you deploy this, and if the smart contract is well written, you have an audit or something, then you will not struggle, and that's why there is no human error if you write that properly. And then it's accurate because this is like either black or white. The smart contracts are really deterministic. The whole blockchain is deterministic, so you will know always what will be the outcome of certain actions. Okay, so this is a basic structure of the smart contracts. This is how you will always see the different smart contracts. In the top, we have a license that always needs to be there. I don't even know what the license is for, kind of like to reproduce and use the code. I always use the MIT as a default. Then we have the Solidity compiler. They need to write pragma Solidity. The latest version is something like 0.8.3, something like that. Then after that, we have this keyword contract, and then we can put any name. In this case, I put my contract. And then we have some specific things. There are the variables, the events, the constructor, and the functions. We are going to explore everything today except for the events, because I don't want to overwhelm you with a lot of information. My main goal today is to help you to get started and be able to build something after this workshop. Perfect. So this is I would say, the best tool to write smart contracts and to get started. Remix ID, if you want, you can start going there. Remix.ethereum.org. This is really easy setup. It will help you to have a quick testing with a virtual machine from the Remix. So that's really fast and also easy deployment as well. Okay, so if you go to Remix, let me actually do this really quick. You can do two things that are the main things that you have to learn today with Remix. That is compile and deploy. So if you want to compile a smart contract, we are not going to write contracts yet, but let me show you this one. This is something that when you go to Remix, this is what you will look. Then you can go to contracts, and then let's use this storage contract. Then when you go to compile, Solidity compiler, you can check this little auto compile here. So then it will always compile all the time. When you edit anything, like something here, that will auto compile right away. So you don't need to compile and click here all the time. So when you see this little check, it's because the compilation was successful. And then the second one is this deploy and run transactions. So Solidity Remix gives you different virtual machines. That's just like a testing blockchain. For example, if you use this Shanghai, this gives you 15 accounts with 100 Ether, like testing accounts. And then you can deploy the contract just by typing here, and then you have the contract, right? In this case, we are not going to talk about this contract, but just to kind of show you how to compile and deploy with Remix, but we are going to go in like deeper into this later. Let's continue. Perfect. So for the ones that are already familiar with coding, we have a lot of different variables in Solidity that are really similar to the rest of the programming languages. We have Boolean, integers, bytes, strings, arrays, structs, addresses, and if you want to learn more about the other ones, they're there, but these are the main ones. The ones that we are going to use today are the ones in orange, so integers and addresses. I would say that those two are the most important ones, with mappings as well. We are going to talk about mappings. I think that's the best Solidity data type that we have, because it's really useful and easy to use. And then we have something that is called Solidity Global Variables. This is really important because this allows you to access some specific variables just in Solidity, like the message.sender. So when you send a transaction or you make a call to the blockchain, this message.sender is telling you the address that is called in this transaction. We also have the message.value. If you call a function and you are sending Ether, you are sending any value, this will tell you the value that you are sending. Block timestamp, you have different variables with the block dot, and then you can explore more different variables. In this case, this timestamp is the time, in case that you want to access to the time. This timestamp is a Unix measure of time of seconds since 1970. So that's just like a lot of numbers. We'll see that one later today as well. If you want to access to the address of the smart contract that you are developing, so you can use this address parenthesis this. And if you want to access to the balance of that smart contract, then you can use this address this dot balance. We are going to use this one. That's why I put it in orange, because we are going to use those ones today. Okay, function types. So there are two types of functions. This is really important that I want you to take a photo of this. We have two main types of functions in Solidity. There are writing functions and view functions. The pure, they are not really important today, but the main ones are view. This view helps you to kind of call the blockchain and retrieve data. And when you do these calls, that's free. You don't need funds when you call these functions. But then when you call writing transactions, that means that you are sending a transaction and changing the state of the blockchain. So you are saying something, you are doing something in the smart contract. So that's why this one requires a wallet. This one requires funds. And the pure functions, that's just something simple that also doesn't require any funds. But that's more like for arithmetic operations or some things like that. That doesn't really use. The main ones are the ones in orange. That's the ones that we are going to explore today. And then we have something else that is called function visibility in all the functions. The main one that we are going to explore today is external. This external is functions that allows you to, you can call these external functions from outside of the smart contract. So any wallet, any account, or any smart contract can call these functions within the smart contract. Then the public is similar. The difference between external and public is the public one can be called within the smart contract, but the external cannot be called within the same smart contract. So that's just a lot of connection of smart contracts in the blockchain. But that's why external, if you know external, that's enough to get started and to build things. We have privates as well and internals, but that's out of the scope for today. Okay, and block explorers. Are you familiar with block explorers? Do you know what's a block explorer? Okay, so then let me show you a block explorer. If we go to ETHOxford.io, this is something that allows you to see all the blockchain, what's happening in the blockchain. So for example, this is the Ether price. You can see the transactions here. This is the latest block that was minted. And you can see all the different things. This will be important for today as well, because once we deploy a smart contract, we are going here, and then we will see if the smart contract was successfully deployed or not. But we are going to use the Mumbai one, this one. And EtherScan is just the block explorer of Ethereum, like the mainnet. Sepolia is a testnet for Ethereum, and then Mumbai.Polygon is the testnet of Polygon. Okay. And then in blockchain interaction, we are going to talk about what's Web3.js, so you understand why this is useful in this, in the workshop today. Then the dApp communication flow, we are going to see the structure of the Ethereum transactions, providers, wallets and accounts. We are going to see how to deploy contracts and how to call reading functions and writing functions as well. Okay, so what's Web3.js? Normally, if you want to interact with any smart contract or anything in the blockchain, you need to use the thing that you see at the top, that weird RPC call. That's called JSON RPC API, and that's really complicated. If we want to build apps and you need to send that JSON RPC, that's really complex for the developer experience. So then Web3.js is here to help you to have a better developer experience interacting with the blockchain. We are going to use this a lot, so you just need to import the Web3 module with the W uppercase here. Then we just need to import the Web3 library. We initialize a provider. This provider is just like a RPC endpoint, like a blockchain node. So every time that you change the endpoint here, that will talk to that specific blockchain. We are going to talk about that deeper later. And then this is how you can get the latest block number, for example, in Ethereum. So you just use web3.eth.get block number. And this is how a dApp normally works when you make a dApp in the blockchain. So first you have the dApp. This dApp is using Web3.js. Then Web3.js will have this RPC endpoint. Today we are going to use a quick node, or it can be anyone. And then this endpoint will talk to the node, and then the node will do a transaction or will return the value of whatever that is needed that you are sending to the blockchain. This is the structure of the Ethereum transaction. So we have all these different fields. You don't need to know all of them because Web3.js is managing all these things under the hood. So you just need to know the from. The from is who is sending the transaction. The to is the address of who you are kind of calling a smart contract, or maybe if you are sending value to a wallet in the the Ethereum. Then we also have value in case that you are sending value to the Ethereum mainnet. If you are sending Ether, and the input data. Now we are going to talk about this for today. We are going to see them, so I put them in green. Okay, so providers. This is something that we are going to write today a lot. We need to import the Web3 library, and then we need to initialize a provider with a URL. If you want to get some providers, you can go to chainlist.org. And here we will see a lot of providers. Maybe you can start going there, and you can type here Mumbai, and then you type in include testnets. You check this, and then you will see here Mumbai. And then you will see a lot of providers that are just these links. And yeah, we're going to do this in a few minutes, but yeah, you can start going to chainlist.org. Okay, and then wallets and accounts. These wallets and accounts are important when we want to call writing functions in the blockchain because, well, as I told you, we need to have funds and we need to have a wallet if we want to send a transaction. So this is how we initialize a wallet using Web3.js. We just use provider.eth. Everything is provider.eth, so you need to learn this, to put this in your memory, to take a photo of this provider.eth, .wallet.add, and then you will have a private key. Are you familiar with private keys? Do you know what's private key? Yeah? Okay, perfect. Perfect. And then with your private key, you can initialize the wallet, and then to access to this wallet, the wallet is an array, so you just access to the first position of the array by just typing wallet 0.address or .private key, and then you can access to this wallet that you just initialized. So the main difference of providers and wallets is that with the providers, you can make calls. So you can call reading functions that just return a value. You have a question? And then what, sorry? And then it was I didn't get it. See, I defined the wallet as a constant, and then the array, yeah, because the wallet is an array, because you can have several accounts. Yeah, in this case, this will be the account in the first position. Yeah, if you have several accounts, then you can just, instead of 0, you can have 1, or 2, or 3. Yeah, that's great.
Will we be able to get a presentation of the...
I will represent the Web3.js Twitter. If you want to follow now, it's Web3_JS, and I will share the presentation as well. Yeah, this is just theory, but that will be useful if you want to do some things. It's just easy to come here, and you can copy paste the code. So you can just come here, copy, and use it. Okay, to deploy contracts, this is also the code that we will need. We will need two things for deploying contracts. One is the ABI, and one is the bytecode. The bytecode is just a huge like piece of numbers that is a kind of the way that when you talk to the computers, you talk in binary code, right? But in Ethereum, you talk in opcodes, and this is the bytecode, just a lot of numbers. We don't really need to know the mechanisms of this. We just need the bytecode to be able to deploy the contract. And the ABI is important for interacting with any contract. So that's also important that you know the ABI, how we can get the ABI and the bytecode. So if we come to Solidity, and we come to Solidity to Remix, and we come to Solidity Compiler, you will see that here we have ABI and bytecode. So that's something important that you have to know today to get these two things. Okay, this is how we call reading functions. We just need to initialize the contract. So in this case, new provider.eth.contract. We send the ABI and the address of the contract if the contract is already deployed. And then to talk to any function of this contract, we type my contract.methods, the function name that we are calling, and then .call. And then in this case, we are going to get the value returned by the smart contract. And then to call writing functions is really similar. We just initialize the contract, the same thing, new provider.eth.contract. But the only difference here in my contract.methods.function name is that instead of .call, like we have here, we need to put .send, and then we need to specify who is sending this transaction. So that's why you need to initialize a wallet, and then you need to put that you are sending the transaction from this wallet 0.address. Okay, perfect. That's the theory. Anyone has a question so far? Okay, perfect. So let's go to Remix, and then let's go here to File Explorer. I'm going to create a new workspace. So I will click in New, Create New Workspace. It can be blank. Okay, and then we have this. So I have 3 smart contracts today that I'm going to share with you. The first one will be a counter smart contract. This is a simple smart contract that will allow us to have a main variable that is just a number, a function to increase this number, and a function to retrieve the current number. So let's see how we can do this. First, I need to create a file here. Just create a new file. Let's call it my counter.sol. This is Solidity. If you get any questions, feel free to ask me, to interrupt me. Don't be shy. The first thing that we have to do is to add the license. So we can type spdx-license-identifier MIT. For the compiler, what we can do, let's zoom in a little bit. Yeah, is that okay for the zoom? Yeah, perfect. Then we need to specify the compiler. In this case, can be 0.08. Can be any compiler. So we have the compiler, we have the license, and then the contract keyword, and then here is the name of the contract. Let's put it ETHOxford, for example. And then we just open the keys here. Okay. Someone remember the structure of the smart contract? What is inside here? Anyone? Okay. Perfect. Something else? Okay, functions. That's perfect. We will have writing functions, and then we will have reading functions. And the state variables. That's the main thing that we have in the top. The constructor is a really important one because when you deploy the smart contract, you only deploy a contract once, right? And once you deploy this contract, then this contract is immutable and no one can edit the code. That's one of the magic of blockchain, that everything is immutable. So this constructor is just a function that can be called when you deploy the contract. In case that you want to do, you will see some specific use cases for the constructor. So the state variable in this case will be a unsigned integer. So you need to type UN256. That's a really used variable. And then the name of this variable. Let's call it my number, for example. Okay, so now we have a state variable here. To write the constructor, we just type constructor, parentheses, curly braces here. And then for the constructor, if you want, we can not put any constructor. That's also fine, or keep it empty. But let's say that I want to start a counter in 10. So if I want that, I can put this my number 10. So when we deploy the smart contract, the value of my number will be 10. But to make it even better, what we can do is to send a parameter in the constructor. So when we deploy the contract, we can choose any number instead of hard coding this 10 here. So we can put UN256, and let's call it the starting number, for example. So now what happens is that when we deploy the contract, we will send a number here, and that will be the starting number of the counter. Okay, and now we can write the functions here. So we just put function, then the function name. Let's call this one increase by 1, for example. Then is external because anyone can call this function. And then we can just increase the number by 1. If you want to make this shorter, what you can do is just to put my number plus plus, and then that will happen. When you call this function increase by 1, this my number will be increased by 1, right? Easy to get that. And then we have a reading function here. So this reading function will just retrieve the value of this variable. So let's call it get counter, parentheses, external. You always need to put the function visibility in every function. But something important with the reading functions is that you always need to put the keyword view, because this is just to view data in the smart contract, and this will not change the state of the blockchain. And then we also need to type returns and put the value that is returning. In this case, because we are returning this number, and this is a U into 56, we put here returns, in parentheses U into 56, and then inside the function we just put return my number, the name of the variable, and we are returning this. Perfect. I would like to know if someone has any questions. Are you able to follow this? Clear? Okay, that's a good question. Yeah, there's some visibility here. You can put it private or public. Let me actually show you the difference. Something that is a better practice is to put them private, right? When you don't put anything, it's private by default. So if you put them public, that will generate a getter. Like instead of this get counter, that will generate a getter. Let me show you this. So we just need to deploy in this virtual machine, and here in the constructor we need to set the starting number. So let's say that we're going to start from 10. So I deploy, and then we have the contract here and deployed contracts. Oh. Ooh. Ooh. I don't know what happened. Okay. And okay, I think that will work now. Yeah, we messed up with this now. Oh. I don't know what happened. Are you able to call Simon, please? Yeah, I don't know what happened. Sorry? Are you able to hear me again? Okay, perfect. Oh, the photographer just, okay, he's not here, but that's fine. Okay, so then, yeah, we're talking about the public and private. So right now, I put this variable public, right? So when we have the public variable, we can see that we have a function that is increased by 1 that we created here. And then we have a function that is get counter that we created here. But then it automatically creates my number. This my number is just the name of the variable because we put this public. So when you put this public, that generates this getter automatically. So if we click in my number, this is getting the 10 because when we deploy the contract here, we send a 10 to the constructor, so that was the starting number. And then if we put the get counter, we are also getting a 10, right? So that's basically the same, but a better practice is to have that into a function instead of having the getter public. And then if we increase by 1, so I just click here, and then we get counter, now it's in 11. So anyone has any questions so far with this smart contract? Are you able to follow this and deploy in the Remix virtual machine? Yeah? Okay, perfect. That's great. So now let's do something a little bit better. Oh yeah, thank you. Thank you so much. Let's create a folder in your computer. Let's open VS Code. So we can use some JavaScript now. I will create a folder called counter. Okay, so I just created a folder called counter. I will open this in VS Code. Let's remove this. Okay, so once we are here, the first thing that we need to do is to create a node project. To create a node project, we just need to type npm init-y, and then you will see this package.json. So now we have a Node.js project. The second thing that we have to do is to install Web3.js. To do this, we need to type npm install or npm I web3. And we will see that listed in the dependencies here. In a few seconds. Okay, so now we are ready to use this. What I'm going to do is to create different files. So one will be for the smart contract, so let's call it counter.sol, the bytecode.json, the ABI.json. These are all the things that we need to be able to interact with the contract in JavaScript. And then let's create different scripts for the different functions, to call different functions. So one can be increase.js. So here we are going to create the script to increase by 1. And then the other one that is getCounter.js. Okay, so the first thing is the contract. I'm just going to copy paste what we have here. Just remove this one. Okay. So I have the contract here. If maybe you don't have this Solidity logo, then you can install the extensions as Solidity. Any Solidity extension will work. Just put this. Okay. The second thing that we need is the bytecode. So remember that to get the bytecode, we can come to Solidity compiler and then copy paste the bytecode here. We need to put this into the quotation marks. So we have a string. Then the ABI, also just copy paste the ABI. Okay, now we're ready to go with the bytecode here and the ABI. All the different like hexadecimal values in Ethereum needs to start with 0x, so we can put a 0x in the bytecode here. Okay, and then we have this. This is ready to go. So now we can deploy the contract. So let's create a deploy.js. Okay, so now this is getting better. This is something that would be really useful if you want to participate for any of the bounties for any EVM network. So this is how you deploy a contract. What we need to do first is to import Web3, the bytecode, and the ABI. So to import the Web3, we need to type this, Web3. So that's how we import the Web3 module. Then to import the bytecode, require, and then bytecode. And then to import the ABI, it's the same, ABI. Perfect. Here we are just importing the things that we need, the Web3.js library, the bytecode, and the ABI of the contract. Then the second thing that we need to have is the provider. So the provider, this is a really important thing to know. Initialize provider. So const provider equal to new Web3. And then here you need to put the RPC endpoint. So let me show you something here. We come to chainlist.org and we, for example, use Ethereum. That would be the first one. And we get, for example, this ETH RPC YAMA. RPC lemma. Now we are talking to the Ethereum mainnet, right? So for example, just do this to show you. We need to write a asynchronous function because everything will be async away. So if, for example, we put await provider.eth.get block number, we are getting the latest block number of the Ethereum mainnet. So for example, let's call this block number is, and then let's put this block. Okay. So if I call this one, this is the block number of the Ethereum mainnet. And now we want to talk to, let's say, Polygon. So we just come here, we type Polygon, we get the RPC from Polygon. We change this link of the provider. And now we are talking to Polygon. So this is something really important that was like a game changer when I was learning all these things, because I thought that to be able to deploy on Polygon or to interact with Ethereum, I have to learn something different, but it's literally just changing this link. So if you change this link, you will talk to different networks. So the one that we are going to use today is Mumbai. So we need to get one RPC provider that starts with HTTPS, because these WebSockets are for events. That's a different thing. So let's put this Mumbai. The issue with these RPC public providers is that sometimes they fail. So that's why normally when you want to participate in a hackathon or to build something, you can use, for example, Quick Note. You create an account. At the end, I will give you a QR code if you want to get like a free account for 3 months. And then I have this RPC provider that will be really fast and hopefully it will not fail. So now if we call this, we are talking to Mumbai testnet. Perfect. And then this is the block number of the Mumbai testnet. So yeah, now you know how to interact with different blockchains. Yeah?
What do we get changed in the provider?
What?
What do we get changed in the provider? How does it depend on, like?
Oh, because the provider is just talking to this link that you see here. Okay. So this link is pointing to a blockchain node in a different network. So that's why you just change the link, and then the Web3.js is talking to that node of that network.
Okay, it's a specific node.
Yeah, on that specific network. Yeah, it's a different network, a different node.
Okay, cool. So this is an address to a node.
Yeah, exactly, a link to a node. That's basically a provider. Yeah, and then just change the link, and you will be able to interact with that blockchain. Perfect. So then let's remove this. Now we know how to talk to the blockchain. So if we want to deploy the contract, let me write the steps here. First, we need to initialize a wallet, because when you deploy the contract, you need to send a transaction to the blockchain to deploy this contract. So we need a wallet with funds, of course. Or if you want to get funds, you can come to mumbaifaucet.com. And then here you can put your wallet address. So in this case, I think you need to create an account here, but that's free. And you can get 0.5 Mumbai. Let me use, for example, the account 5. Well, are you familiar with MetaMask? Yeah, who is not familiar with MetaMask? Okay, perfect. So then let me go back so you don't get lost here. If you install MetaMask, you will see this pop up here, and you have different accounts. Normally, you will see 0 in everything, right? Because you will not have any funds. Something really important is the network that you are using. You see the network here in the top left, so you can change to different network. You will have Ethereum mainnet, Linea, all these things by default. The one that we are going to use is Mumbai. And if you don't see a network, you can come to chainlinks.org as well, and then you can click in Add to MetaMask. So when you click in Add to MetaMask, this will, maybe because this one is already there, it will not work, but let me add a different one. For example, Arbitrum. Yeah, add Arbitrum, and then you just click in Approve, and now we are interacting with Arbitrum. Yeah?
So what exactly does the RPC do again?
They have a connection to a node, so they talk to a node, because in the background they have a node, and if you want to interact with the blockchain, you can set up your own node, but then that's too much. That's really complex, right? So then what we do is just to use these RPC links and they already have a node in the background, and then that helps us to interact with the blockchain. Yeah.
That list of providers is like a public pool of available nodes.
Chainlist.org, yes, but then there are other private providers like QuickNode, Alchemy, and there are more. Like there are a lot of RPC providers. But if you want to just be quick, you can use Chainlist.org, and these are public.
Them, yeah?
Sorry?
It's like a public pool for
Yeah, exactly. Chainlist.org is a public pool for providers. Exactly. And yeah, and then that's how you use MetaMask. So you install the Chrome extension, then you will see this extension here. Important that you are connected to Mumbai, right? Not Arbitrum. So we come to Mumbai. And then you will see, I think you will see just one account by default. And then if you want to create more accounts, you can just create an account by clicking here in Add Account, add a new account. And then let's actually play with this one. Let's say Oxford. So now I just create an account. And an account, for the ones that don't know what an account is just a pair of a public address and a private key. So let me just show you really quick this account. This will be the address. If you copy paste this will be the address. This is a 20 hexadecimal number. And then the private key, if you want to get the private key of this account, you click here, account details, show private key. Then you put a password. You need to set up a password in MetaMask. And then this will be the private key of this address. So then we have this private key. So this is just an account is a pair of a public key, an address, and the private key. So these are these two in this case. Yeah. So now you know how to create an account, and then this account can be the same address for any of the EVM blockchains. So this can be for Ethereum, for Polygon, or for all of them. We also have Avalanche here, for example. So if we want to do something in Avalanche, the same thing. We just add Avalanche to MetaMask. We just change the RPC provider, and then you're deploying on Avalanche now. Okay, perfect. So now let's deploy this. We have. Yeah.
Just go over the concept of the network within MetaMask again.
Like setting up this MetaMask.
Yeah, the top left.
Oh yeah, perfect here. Yeah, so there are a lot of different blockchains, a lot of different networks. Ethereum, Binance Smart Chain, Polygon, Arbitrum. So here in the left, you can connect to a lot of different networks. But in this case, because we are interacting with Mumbai, you need to click in the top left to see all the different networks that you have in your MetaMask. And then you are interacting with Mumbai right now. So if you don't have all of these networks here, that's why you can come to chainlist.org, look for the network that you want to interact with. For example, Optimism, and then you can add to MetaMask. And then you will see that Optimism now will be added to my list of networks. Let me show you.
Thank you.
You're welcome. Yeah, you have it here now. So we have Optimism, we have Arbitrum, Polygon, Mumbai. Yeah, in case that you don't have Mumbai, that's the one that we need for today. Perfect. So now that we have this in Mumbai, we need, oh yeah, let me just send me some funds in this Mumbai faucet, because remember that we need funds to be able to interact with the blockchain. So I just put send me Matic. Okay, and then you see right now that I have 0, but in a few, okay, that was quick. But now I have 0.5. Now, yeah, let's deploy the contract. So to initialize the wallet, this is always the same. After you do this a couple of times, you will get used to the same process. Initialize the wallet, initialize the contract, and then deploying. So yeah, it's just a matter of repetition, and it will be easier. So we need to create a constant wallet, and then provider.eth. This is always the same, provider.eth, .wallet.add. And then let's add the private key that I have here. Remember that it has to start with 0x. Is that a good zoom? Yeah, that's fine. Yeah. Okay, so now we have this wallet. If you are curious of what the wallet is, so let me just show you so you understand what's this. Okay, so this wallet is an array, and as you can see, we have only one account, but you can add several accounts to this wallet. Here is the address. Here is the private key, and there are different methods that we can use. So yeah, this is the wallet. After we initialize the wallet, we need to initialize the contract. After that, we need to create contract deployer. This is only when you want to deploy contracts. I will also show you a different way to deploy contracts that is easier. And then send the transaction. Perfect. So to initialize the contract, we need to create a contract instance. Let's call it my contract. New provider.eth.contract with this C uppercase. And then here we need to send the ABI. So that's why this is important. This ABI here. Perfect. So now this contract will be able to, like, we can call this contract by just sending this ABI. You will see what happens when we have this ABI. This contract deployer is a specific thing that we have to do only for deploying contracts in any network. So this will be something like const deployer, and then we use the contract instance, that is my contract.deploy. And then we need to send an object here. This object will have two main arguments. One will be the data, and the other one is arguments. So this data will be the bytecode, because when we are sending the transaction to the blockchain, what we are sending to the nodes is just this whole bytecode. So what is being stored in the nodes is this thing. And then this whole number is just like a set of steps. So when you call the smart contract, that will interpret like that opcode. That's called opcodes. And then this smart contract has some specific steps, and that's the translation of the opcode to the numbers and all this like a string that we see here. So that's why we need to send the bytecode just to deploy the contract. And then the arguments, who can guess what the arguments are here? Any idea?
Balance or amount of money you want to transact?
No, these arguments will be what we want to send to the constructor. So in this case, the constructor of the contract will be the starting number. So if your contract don't have any constructor, you just need to put the data. You don't need anything else. So yeah, but in this case that we have the arguments, we need an array, and then we can send a number. Let's send 77. So the starting number of the contract in this case will be 77. Okay, and then we need to send the transaction. How we can send the transaction? That would be deployer.send. Remember that always to send a transaction, we just use the .send, and we need to specify the wallet that we are using. So in this case, from wallet0.address. If you wonder what's the .address, let me just print that here. And then you can see it here. Okay, perfect. This will return, all the transactions will always return a transaction receipt. So we can put this await and const transaction receipt. Perfect. And now we are ready to send this transaction. And then if you want to get the address of this contract that is being deployed in Mumbai, so let me just put this code here. You can use the transaction receipt .options.address. And then here we are going to get the address of the smart contract. Any questions so far with this deployment script?
Yeah, so wallet's address will be public key of your Oxford account.
Will be this one, yeah.
Yeah, okay.
Yeah, so something else?
Also, could you please quickly go over API JSON file?
Yeah. The API is just a translation for the JavaScript to talk to the contract. So if you can see here, all the different state variables or functions are in a specific JSON format. So when you send any transaction, this will be decoded because you need to talk in a different, that's a little bit more complex. But when you call a smart contract, what you need to do is to hash the function name. And then once you hash this function name, you send a transaction, right? So what this API is doing is just making it easier for JavaScript to be able to send the transactions. You don't even need to know what that is, just to know, that it's useful to initialize the contract.
It's kind of a dictionary.
Yeah, a translator that will help JavaScript to talk to that contract. Yeah. Because if you put that wrong API, then that will call a function that is called, I don't know, a function that can be called send me money, but if that contract doesn't have the function that is called send me money, that will not work. So that's just something like to match, yeah. Okay, perfect. So Now hopefully this will work. Oh yeah, I print the whole wallet here. That's why I have this thing. This is the wallet address that we printed here. And then finally we have this address here. Let me actually just deploy it again. So we just remove all this spam. Yeah, so then this is the wallet address. And here we will have the contract address. So now, if we go to mumbai.polygon.scan, and we paste this address, we will see that there was a contract creation here. Like we just deploy a contract in Mumbai, right? And if you go to contract, we can verify the smart contract. So everyone will be able to see what is this smart contract code. And that's something really common for transparency, because if you want to interact with a contract and you don't see the code, then that's a tricky thing because you don't know what you're calling, right? So then you click on verify and publish. We have here the contract address, compiler type. This is just a single file because it's just one file. Then the compiler version, we have 0.8.0, I guess. Yeah. Then we need to copy paste all the smart contract code. Oh yeah, the license, MIT license. Continue. We copy paste here all the smart contract code. And then we just verify that we are not a robot. Cars. Okay. I think it's these ones. Verify and publish. And this sometimes doesn't work, but hopefully it will work now. Okay, successfully. So now, if you come to contract, now this will have this little check because the contract is verified. And then you will see the contract code here. This is something really important when you interact with the smart contracts. You can just come to the ETHOxford, the block explorer that you're using, and then you will see this little check. This doesn't mean that the smart contract is secure. This just means that the smart contract that you're interacting with is this code. Maybe this code can still be malicious code, but at least you can see it, right? So that's why it's important to understand Solidity. And we can also interact with this contract from the block explorer. In this case, we can call read contract. Remember that we have two functions, reading functions and writing functions. So for reading, we can just get counter, and we have the 77, because we just send the deployment with the 77. And then the write contract functions will be to increase by 1. But to increase by 1, we need to connect the wallet. So I can connect my wallet here, MetaMask. Let's see which wallet was connected. Connect. Perfect. So we have this wallet. I need to connect the wallet that is 359. Okay. So we just connect the wallet. 359. Perfect. And then increase by 1. We just click and write. MetaMask will pop up here. We just confirm. And then we just, if you want, you can see the transaction here, and everything is until it's confirmed. So we have the from, that is my address, my contract address. The to, that is the smart contract that we are calling in this case, is still pending. That hopefully will be, okay, success. And then we can see here that the function that we call was increased by 1. And this is basically what the API is doing. The API is decoding this increase by 1, translating into this code. So every time that you want to call a smart contract, that's a little bit more advanced. You are calling the function, the hash of the function. So this is what you are calling in this case, but that's what the API is kind of used for. And then if we come back to the smart contract, to the reading, now we have 78, right? Any questions so far with the block explorer, with the smart contract? Clear? Perfect. Now let's write another smart contract. Yeah, I think we have some time to write another one. Okay, so we have a buy me a coffee contract. Now here it's getting a little bit better. What I'm going to do is to create a Solidity file. Let's call it coffee.sol. Let's copy paste these two things that we don't need. The license and the compiler version. Then the contract keyword, and then let's call this coffee. Okay, and then we will have variables, constructor, and functions, right? For the variables, I specified that here. We will need a state variable that is called owner. So this owner will be the owner of the contract. Because if I do you know what is the concept of buy me a coffee? Do you have any idea? Okay, so normally in programming and this type of open source things, instead of asking for donation, you just say like buy me a coffee. And then instead of just give me money, it's just a nicer way to say give me some donations. Just buy me a coffee. So this is a contract that basically will receive donations, and then you can withdraw these donations. So that's why we are going to have an address that will be my wallet. Otherwise, if we don't have my wallet, then anyone can come here and withdraw the funds, right? So then this will be my address. We are going to have these three functions: one to donate, one to withdraw the funds, and one to get the current balance. Here we have a new concept that is called payable function. We're going to talk about that. So in the constructor, what we are going to do is to set up the owner of the contract, right? So we need to send an address in the parameters here. That can be wallet. So we just type my wallet equal to this wallet that we are sending in the constructor. Any questions so far with this? Is this clear, the constructor and the address? Perfect. Then we have the functions. So we are going to have the donate function. Will be external because anyone can interact with this. But then we have a new keyword here that is called payable. This payable keyword allows this function to receive ethers. Otherwise, you cannot send ethers to this smart contract. When you want the contract to be able to receive ethers, you also need to add this receive external payable. Just that keyword. That's something like a standard that has to be there to add these two things. If you want the smart contract to be able to receive funds, you need to add the receive external payable function, empty, you don't have to do anything, and then we can add this donate payable function as well. And then you can do whatever you want here in this function. I'm not going to implement anything. We will just have it there. Because the donate function, what we'll do is just to receive the value. And you don't need to do anything to receive the value. When you send the transaction, the person that is sending the transaction is setting up the value in their transaction. So they don't need to interact with the contract to send the value itself. For example, if we deploy this in this virtual environment, and then we put, remember that we need to add our address here. So let's just add this one, for example. Now the contract is deployed, and then we have this donate, right? It's red because it's payable, so that's a new concept. And then if you want to send the value, you can set up the value here. So let's say that I want to send 80 ethers. So we just click in donate, and now the balance of the contract is 80 ETH, as you can see here. So now this contract has 80 ETH. So now let's implement the function withdraw. So we are able to get the funds. Otherwise, if you don't implement the withdraw function, this 80 ETH will just be stuck there for the rest of our lives. So that's why it's important to have this as well. This will be external. And then what do you think, guys, that we need to implement in this function? Any idea? In normal words, it doesn't have to be in code. What is this withdraw function? Okay, to where? Where do we need to send those funds? Okay, the address. Yeah, always the address is kind of your bank account address, and then the private key will be the password that allows you to get into that bank account. So you always share your bank account address, but you never share your password, right? So it's the same here. The same. It's only, yeah, you never share the private key, never, anywhere. Yeah, actually, normally when you want to implement this type of things, you shouldn't push this to GitHub, for example, because then people will be able, I mean, if it's a testnet, that's fine, but if it's real mainnet, you don't need to put your private key here, otherwise you can lose the money. Yeah, and then we have this withdraw here. So how we can send these tokens? So what we need to do is first to get the balance of the smart contract. So to get the balance, this was in the presentation as well. We just type address.this.balance. So this will be able to retrieve the current balance of the contract. And then we need to make the transfer. So let me just put a comment here. Get balance and transfer funds. So to transfer funds, we can access to my wallet variable that is storing my address, right? And then we have a new keyword here that is called .transfer. And by using this, you are transferring funds to that wallet. And then here we just send the balance. That is what we are kind of getting from this variable here. And then something important is every time that you want to send funds to any address, you need to put payable keyword as well. So we just put payable here, and then this function is ready to go. Perfect. So now let's deploy this in the virtual environment. Let's put this address here. Actually, let's put the last one. Yeah, let's put this address. Oh, let me add actually something else that would be nice to add, like a require. A require is just like a if and else that you can add here. So let's put require, and then the message.sender is the person or the address that is calling this function. So I will put here message.sender must be equal to my wallet. So do you know what this means?
Only you can withdraw.
Exactly, so only you can withdraw. And then you can put an error string here that says you are not Santiago. So only Santiago can withdraw in this case. So let's deploy this contract with this address here. So only this wallet, the last one, can withdraw the funds. But anyone can donate because we don't have anything here, right? So if we open this and we put 80 Ether and we click in donate, now we have, oh, let's see, this didn't work. Oh, I don't have 80. This one, yeah. Now we have 80 ETH in the balance, right? And then if I try to withdraw with this account, with the first one, we'll have an error here that says you are not Santiago, right? Because only Santiago can withdraw. So if I come back to the last address that we have here and I try to withdraw, then now we have the balance of the contract is 0 and the balance of this account is 180. Perfect, yeah, that works. Any question here?
Yeah, for withdraw function, can we change it from external to any other modifier?
Yeah. It can be public as well. If you want, let me just show you like a really quick difference of if you put it private,
yeah,
that will not work. Like that will not be able to call externally. So let me show you. If we deploy this, look at that, it's not here anymore, right? So private functions are you can only call private functions from the smart contract itself. But then we can call, for example, function withdraw to. And then this function can be external and can call this internal one, like withdraw. And then this will work. So let me show you. If we deploy this, look that withdraw is not here, but then withdraw to is doing the function of withdraw because we are calling it. So yeah, you can have it public or external, but then private or internal will not be able to call it from outside. Then you will need to add a require like that. Okay. It has to be like manually like that, but yeah, then you can put message.sender equal to the wallet.
Okay. But you can't solve it with modifiers.
Yeah, no. I mean, you can create a modifier. That's actually a different thing that exists. That's called modifier, and then you can add only this wallet. Okay. And then this is something that you can put. Require, the same thing here. It's literally the same, but it's just easier to put the require inside the function. And then that's kind of like the step that it needs to validate first. Okay, I think, yeah, let's just do the last thing here with JavaScript so you're able to get the counter here. Let me just do this. The last like 5 minutes and we are done. Okay, so here we have the same thing, the Web3 library, the ABI, so we can interact with the contract, and then the provider. And then what I'm going to do is to get the counter of our contract. So for that, we need to initialize the contract and then make the call. So to initialize the contract, we just need my contract equal to new provider.eth.contract, and then we have the ABI, but then we have something new that is the contract address. Because now the contract is deployed, right? So we can call this a smart contract, and then to make the call, is just like this: my contract dot methods, and then the method that we are calling is get counter. So in this case, this is using the API to talk to that function. Dot call, and then this will retrieve the result. In this case, will be the counter, and then we can just print it here. Current counter result. Perfect. And if we call this not get, oh, and use this await.
What determines when we use VS or Remix? What do you
with Remix, you cannot build apps. Remix is just for smart contract and testing. So if you want to make smart contracts, that's really useful. You don't need JavaScript. But JavaScript is when you want to make dApps and you want to have a backend or a frontend. Then Web3.js is useful in this case. And yeah, then here we just call this. Yeah, and then we have the current counter is 78. And yeah, then that's everything. Do you have any questions regarding this contracts or something?
Could you also please clarify how do you interact with the private ones and the public ones? And is it when you went to the other web page?
To this? Yeah. Okay, when you are here, you can never interact with internal or private ones. You will only see public or external functions. That's why here in the code, we have only two functions: increase by 1 and get counter, and both of them are external. But if we change this for internal or private, we are not able to interact with them. They are not like available to call them. So if you call them, you will get an error. Like that function doesn't exist. Yeah. Any other question? Perfect. So I'm going to share this. Here is the code. If you want to check here in the title, I just publish everything here in this repo. We have the counter, we have the buy me a coffee, and I have another example that you can explore that is called a scroll contract. Scroll contract is just to get funds in the contract, and when you have certain condition, these funds can be withdrawn. Like you can do something with these funds, or can be transferred to someone. So here we have the scroll contract. Everything is here. You can copy paste this and go to Remix, and then it will be easier to interact from this little interface. This is really useful, this Remix ID, because you just click and deploy, and then you can get started with this here. Then, yeah, here is the other buy me a coffee. Here is the scroll contract with all the different scripts as well for calling every function, like to deploy the contract, to get the number, to increase by 1. Everything is already here, so you can take a look. And then here, these are some really important things that you can learn. The first one would be listening to events. If you want to understand how the breaches works, this is really useful because the events is like something that can be emitted, but this is not stored in the blockchain. So this is really useful. For example, if I have a smart contract and then I have a script or a backend listening to the events, so when the event gets emitted from the smart contract, this can do X or Y. So that's how breaches works. When I buy, for example, USDT in Ethereum, there is a breach listening to this event, and then this will give me USDT in other network. Then we have call functions of other contracts, because you can also make call from one contract to another contract, so that's also important. If you come here, you will see the YouTube videos or the resources. Proxies, this is really, really important. This is the only way that you can upgrade smart contracts, because remember that once you deploy the smart contract, that will be immutable forever. But then with these proxies, you can upgrade the smart contract. So that's a really interesting topic to learn. Smart contract inheritance, to inherit from one smart contract to another. You can learn a little bit about private variables. At the end, the private variables are not, you can call the private variables in a different way using scripts. Oracles like Chainlink, I saw that Chainlink was in the bounties, so you can also learn here how you can call Chainlink oracles. Create a React app will be useful as well, in case that you want to create a app for Avalanche. Sending raw transactions to smart contracts. And then if you're interested in learning more about smart contract security, you can visit this Cyframe thing. It's a really good course for free, where you can learn everything about Solidity and to be a smart contract auditor. Yeah?
Did you see the slides you've got on your Web3.js?
Yeah, I will post that here. You can, not in mine, but I will post in this one. So you can follow us here in Web3_JS. yeah, I will publish that in 20 minutes after this. And then, oh yeah, the last thing, yeah, let's keep in touch. You can follow us at ChainSafeTH or Web3_JS, or you can also text me on Telegram. If you have any questions, I will be here the whole weekend, so feel free to ask me questions. I will be really happy to help you with Web3.js or Solidity. And then something else that we have, but this is more for web developers, are like Web3.js plugins. And oh yeah, then here we have the QR code if you want to get the quick note RPC endpoint. So this provider that I have here, you can go to that QR code, and then you can create an account, and you will get these RPC providers. And then if we have more things for Web3.js, actually something that can be interesting for you is we have a hackathon in 2 weeks, and we'll have 2 different bounties. One is for building a plugin that maybe that's a little bit out of your scope, that is more advanced. But then we have an ideathon. And this ideathon is something that you can do because you don't need to learn how to code. You just need to learn how the blockchain works and how we can bring a better developer experience. So this is something that you can explore a little bit. We'll have $10,000 in bounties. 5K will be for building plugins, and then 5K will be for ideas. So yeah, follow this link, and on Twitter we are going to publish that as well. And yeah, then that's everything. Thank you so much.